Okay, today we are solving exponential and logarithmic equations, and today we'll be using the calculator to the very end. So we're not using the calculator until the last step. So everything is by hand until we get to the final step. Okay, this first section is just kind of a reminder of converting logarithms to exponential form. And remember yesterday I wrote down log base b of a equals e. So if you are given a general logarithm, you need to convert it to exponential form. And using these variables I have over here, which variable represents the base? B, which variable represents the exponent? E. And our answer is the variable a. So b to the e power is equal to a. Now looking at the first column, what is the base? A, and we're trying to find the missing power to give us an answer of 1. So a to what power equals 1? 0. A to the 0 power is always 1. Going down that first column, the base is a. We're trying to find that missing exponent to give us an answer of a. So a to what power gives us a? 1. So we're just looking for the missing power. And for the next one, a to what power would give me a to the x? X. And for this bottom one, now this one's new for today. Notice we have log base a for the exponent. So logarithms and exponential forms are inverses. So it's actually going to cancel out. So a to the log base a will cancel. And what's left? X. Now for the second column, now instead of logs, now we have natural logs. And for natural logs, we still technically have a base here. Now for natural logs, it's not understood to be base 10, it's understood to be base e. So here the base is e. So for this problem, we have to figure out e to what power equals 1 for the answer. 0. So again, for this next one going down, the base is e. So e to what power gives us e for the answer? 1. And the next one, again, the base is e. So e to what power gives me e to the x for the answer? X. And the last one is new for today. E to the natural log power, those are inverses, they're going to cancel each other out. So E, L, N cancel each other out, so the answer is just X. Now the first few examples are just a refresher of what we did yesterday, and we're solving for X. So problem number 1, if you have one logarithm, convert to exponential form. So for problem 1, what's the base? 10. What's the power? X. What's the answer? 10,000. And yesterday we solved these by getting like bases. So what would be the like base? 10. So 10 to the x power is equal to 10 to what power gives me 10,000? 4. So if the bases are equal, the exponents are equal as well. So our answer is just x equals 4. Next one, number 2. What is the base? 10. What's the power? X. And that equals 0.00001. Now to solve this, we're going to get like bases. So what would be the like base? 10. So 10 to the x power equals 10 to what power? Let's see, 10 to the negative 1 is equal to 1/10, which would be 0.1. 10 to the negative 2 is 1/100, which would be 0.01. 10 to the negative 3 is 1/1000, which would be 0.001. So what would the exponent have to do there?
4. 5.
Negative 5. So what's our answer? X equals -5. So So make sure you can do that without a calculator. So if you have to go back and convert to decimal, go ahead and do that so you make sure you get the right answer. Because even if you're one off, is -5 and -6 the same answer? No. So you have to be careful with those. Next one, what's the base? 4. What's the power? X, what does it equal? 4 to the third. So what's our answer?
3.
X equals 3. Next one, what's the base?
10.
10. What's the power?
X.
X, what does it equal?
10 to the 1/6.
10 to the 1/6 power. If you're taking the 6th root, that's the 1/6 power. So what's the answer? X equals 1/6. Next one, number 5. Now this one's not a review problem, this one's new for today. So if you have 7 to the log base 7 power, that cancels each other out. So if you have a log as an exponent, it cancels. And what would our answer be? 2. Whatever's left over is the answer. So the answer is 2 for X. This next one is similar, but we don't have exactly 8 to the log base 8 power. We have this coefficient out front. So if you have the coefficient in front of the log, do the power property and pull that 2 back to the exponent position. So this would be 8. I'm freezing. There we go. 8 to the log base 8 power, and the 3 needs to be squared. And that equals X. So once I pull the exponent back, the 8 to the log base 8 cancels, and what's left?
9.
Yeah, 3 squared, which is 9. So the answer is 9. Okay, now the instructions say to use logarithms to solve, and I added this part in. We are going to round answers to the nearest thousandth. So make yourself a note. We are rounding to the nearest thousandth. And we'll do the same on the homework as well. So round answers to the nearest thousandth. And if we're rounding, that means we're using the calculator, but we're not using the calculator until the very last step. So no rounding until the end. Okay, so for number 7, what we've been doing was get a common base. So can I get a common base with 5 and 10? No. So if you can't get a common base, you will have to log both sides. So whatever you do to the left side, you have to do to the right side. So take the log of the left side. So we're logging 5 to the x minus 2 power. And we are also logging the right side, which is 10. So log both sides. So step 1, log both sides. Step 2, use the power property. So if you have an exponent, you need to pull it out in front as the coefficient. Now if your exponent is a binomial, it has to be grouped in parentheses. So group the x minus 2 in parentheses, and we'll have our log of 5 equals log of 10. Now for this one, I only have x on one side. So to get this x by itself, what if I wanted to get rid of this log of 5? How could I get rid of that log of 5? Divide both sides by log of 5. And this only works if you have x's on one side. So bring down our x minus 2. And leave this written out, log of 10 divided by log of 5. So we're not putting anything in the calculator until the final step. Is x by itself? No. How do I get rid of the plus 2? How do I get rid of the minus 2? Add 2 to both sides to give it away. So this would be x equals log of 10 divided by log of 5. And after you find that answer, add 2 to it. Now we're going to type it all in at one time. But now that we're down to the final step, we will put it in the calculator. And I'm going to use the Inspired. And it was log of 10, so control 10 to the x. If you're on an 83 or 84, you'll have to do second 10 to the x. So it's log of 10 divided by log of 5. Now, if you're dealing with base 10, you don't have to type in the base 10. The calculator will fill it in for you. And then go to the right side of the fraction, and we need to add 2. And we're rounding to 3 decimal places. So behind the 430, I see a 6. So does it round up or stay the same? Rounds up. So our answer is approximately 3.431. And since we are rounding, it's no longer an equal sign because it's no longer exact. We have a little bit of approximation here, so use a wavy equal sign to signify it's an approximate answer. And our answer is 3.431. So don't put it in the calculator until the final step. Next example. Can I get a common base with a 3 and an 8? No. No. So step 1, log both sides. So log the left side and log the right side. So step 1, log both sides. Step 2, use the power property. So your exponents, pull them out front as a coefficient. So the 2x, pull it out front. X plus 5, pull it out front. So this would be 2x times the log of 3 equals x plus 5 is a binomial, so make sure your binomial stays grouped in parentheses. Now if you have x's on both sides, and that's the case for this problem, you will have to actually distribute. So we need to distribute the log of 8. So bring down the left side, 2x log of 3. And distribute x times the log of 8 is x log of 8. And 5 times the log of 8 is 5 log of 8. Now our goal is to get the x by itself. But notice, how many x's do you see? 2. We have an x over here and an x over here. So if you have an x for a coefficient of the log, we need to move them to one side. So if you see x logs, move them to the same side. So I want to get the x's to the left side. So I'm going to move this one that's on the right. So since it's a positive, I need to subtract x log of 8 to both sides. So that's 2x log of 3 minus x log of 8 equals 5 log of 8. So after you distribute, move your x logs to the same side. Now once your x logs are moved to the same side, we want x by itself. So you need to factor out the x. So pull the x out of both of these terms. So when I pull the x out, that leaves me with 2 log of 3. And when I pull the x out of here, that leaves me with negative log of 8. That equals 5 log of 8. Now our goal is still to get the x by itself. So right now what operation is happening to x? It's being multiplied. So the opposite of multiply would be divide. So we need to divide both sides by what's in the parentheses, which is 2 log of 3 minus log of 8. And that was our last step. So now we're ready to put this into the calculator. And if you're using an 84 or 83, if you have more than one term, in the numerator or denominator, you'll have to group it in parentheses. So after you type in 5 log 8 and close the parentheses, and in the division key, then these two logs need to be grouped in parentheses. And on the inspired, we have 5 log of 8. Log of 3, minus log of 8. And again, if you are using an 83 or 84, you have to group the denominator in parentheses. And we're rounding to the nearest thousandth. So to the nearest thousandth, what would our answer be? 88.274. And again, I'm using the wavy equal sign because it's an approximation. It's no longer exact. Next one, number 9. Can I get a common base with a 12 and a 3? No. So if you cannot get the same base, you need to log both sides. So log the left side and log the right side. So step 1, log both sides. Step 2, use the power property. So those exponents, pull them out front and make them a coefficient. And since they are binomials, what do they mean? Parentheses. So x minus 4 in parentheses, log of 12, equals x minus 2 in parentheses, log of 3. Now if you have x's on both sides, you do have to distribute. So distribute the log of 12 on the left side, and on the right side, distribute the log of 3. So distributing the log of 12, this would be x log of 12 minus 4 log of 12 equals, and on the right side, distribute the log of 3. So this would be x log of 3 minus 2 log of 3. And after you distribute, you want your x logs on the same side. So I'm going to move this x log to the left side, but I only want x logs on the left side. So what I'm going to have to do is I'm going to have to take this minus 4 log of 12, move it to the other side. So x logs on the left side, and then constant logs on the right side. So we are first going to add 4 log of 12 to both sides. Move it over here. And to move the x log to the left side, we'll have to subtract x log of 3 to both sides. Okay, so that gives me x log of 12 minus x log of 3. These guys cancel. These guys cancel. That gives me negative 2 log of 3 plus 4 log of 12. So after you get your x logs on one side, factor out the x to get the x by itself. And when I factor out the x, I'll have log of 12 minus log of 3 equals negative 2 log of 3 plus 4 log of 12. Now these problems aren't difficult, it's just a lot to write. And what would be our last step? Divide both sides by what's in the parentheses. So divide both sides by log of 12 minus log of 3. Now we're ready to put that into the calculator. And if you're using an 83 or 84, group the numerator in parentheses, group the denominator in parentheses. And the typing begins. Negative 2 log of 3 plus 4 log of 12. And what did you get to the nearest thousand?
5.585.
I agree, 5.585.
Bingo.
Next example, what does this one say?
Use natural
Use
logs.
natural logs. Instead of logging both sides, we'll natural log both sides. So instead of doing the control 10 to the x, we'll do control e to the x. Okay, so number 10, can I get a common base with 8 and 12? No. So we'll have to, instead of logging both sides, they want us to do natural log. So we need to natural log the left side and natural log the right side. And after I natural log both sides, what's the next step?
Power property.
Yeah, power property, move the powers out front. Now, most people usually skip this step that I just wrote down, and normally just go right to the power property and write down 4x, natural log of 8, equals 3x plus 1, natural log of 12. So if you skip this first step, that's perfectly fine. And if you have x's on both sides, you will have to distribute. So this would be 4x, natural log of 8. This first one would be 3x, natural log of 12. And 1 times natural log of 12 is just natural log of 12. After you distribute, what's next? Subtracting. Yeah, get the x's on the same side, so we need to subtract 3x, natural log of 12. So that gives me 4x, natural log of 8, minus 3x, natural log of 12, equals natural log of 12. And after you get the x's on the same side, what's next? Yeah, get the x by itself, so factor out the x, and when we take out the x, that leaves us with 4 natural log of 8, minus 3 natural log of 12, equals natural log of 12. And what's the last step? Divide both sides by what's in the parentheses, so divide by 4 natural log of 8, minus 3 natural log of 12. And again, if you're using an 83 or 84, you would have to group the denominator in parentheses. Okay, more typing. So for natural log, you'll do control e to the x, or on the 83 or 84, it'll be second e to the x.
Just the ln and log button.
Oh, yeah, just the L and the log button. Oh, no, that's right, 3 natural log of 12. And to the nearest thousandth, what would that answer be? I agree, 2.879. Okay, these last 4, they won't take as much time. But number 11, we have to solve for x. And what does the instructions say? Use natural logs to solve. So we need to natural log both sides, so we'll have natural log of e to the x equals natural log of 10. And natural log of e, what happens there? That cancels, so this is just x equals natural log of 10. Now let's ready for the calculator. So natural log of 10, what's natural log of 10 to the nearest thousand?
2.303.
2.303. We agree? Okay. 4 more to go, so here's number 12. Now this one, if e is not by itself, get e by itself. So how do I get rid of the 3 up front?
Divide it out.
Divide both sides by 3. So that gives us e to the x plus 2 equals, and 25 divided by 3, 75 divided by 3 is 25. I keep wanting to give you answers today. Now, we're still using natural logs to solve. So what do we do next? Natural log both sides. So natural log e to the x plus 2 and natural log 25. What happens with natural log of e? Cancel. So that leaves us with x plus 2 equals natural log of 25. And what would be the last step? Subtract 2 to both sides. So in the calculator, you need to type in natural log of 25 minus 2. And what would that be?
3.135.
3.135?
Yes, ma'am.
We agree?
What did you get out? What?
So it's not 3.135, what is it?
1.219.
1.219? Do
Oh.
you agree with that one?
I did the natural log of 23.
Oh, okay. So 1.219, corrected answer. Now do we agree on that one?
I got the same one.
Okay, good.
No, I still got 3.135. Give me an interesting part.
Okay, number 13. What do you notice with 13?
Already lost.
Yeah, we already have natural logs, and what happens right here? Cancel. So this is natural log of 4.5 equals 0.031x. What's next? Divide both sides by 0.031. And round to the nearest thousandth, and what do we get? 44.719. Do we agree?
I got 48.51. 19.
48.519. Let's see, natural log of 4.5.
That's interesting thing.
Was it 4.5?
Yes.
Okay, that's just weird. Divide by 0.031. Yeah, 48.519. So x is approximately 48.519. And I want you to do number 14. Do 14, we'll check your answers in a minute. E is not by itself, yet E by itself, so what should we do first? Divide both sides by 4. And what's 1600 divided by 4?
400.
400 equals E to the point 045x. What's next? Natural log both sides. And what happens with the natural log of E? They cancel, so it's natural log of 400 equals 0.045x. And divide both sides by 0.045. And what is x to the nearest thousand? 133.144.
Goodness.
Now, your homework does have to be on your own notebook paper, and most of it is on a little handout, but there is parts in the textbook, so don't forget to do the problems in the textbook.